Hello, my dear students. Welcome you all to Sri Jain Rank Zone classes. I'm your mentor and your friend for the subject chemistry, and I will be taking the organic chemistry. My dear students, as you all know, that we have already started general organic chemistry, and today we are going to start with a very important topic, hyperconjugation. Hyperconjugation is also known as Baker and Nathan effect or no bond resonance. Hyperconjugation, it is quite different from the inductive effect as we have learned in the previous classes. It is said to be the delocalization of conjugated carbon hydrogen sigma bond, sigma electrons with pi bond or positive charge or free radical is called hyperconjugation, hyperconjugation or H effect. As we know that order of carcation on the basis of inductive effect is tertiary, secondary, primary, and methyl. Okay, so order of alkyl carcations on the basis of inductive effect we have already explained. Now consider example. If a tertiary alkyl group is attached to a carbon having a positive charge, a isopropyl group attached to the carbon having a positive charge, a ethyl group attached to the carbon having a positive charge, and this is ethyl carpetine. So, according to the inductive effect, the order should be as below. The tertiary alkyl group, it will be maximum electron releasing, it will have or show maximum electron releasing effect. So, the order will be this, then this, and lastly the ethyl cation. But actually, order should be reversed, which is explained by hyperconjugation, which is explained on the basis of hyperconjugation. Okay. Suppose this is the compound. Okay. So the double bond will shift here. The carbon will acquire the positive charge. As the carbon will acquire the positive charge, this bond, this sigma bond electrons will be shifted to here. Okay. So the resonating or the next form is this. So the number of H atoms on the alpha carbon, this is the functional group, double bond. The adjacent carbon is the alpha carbon. This alpha carbon is having alpha hydrogen. More number of alpha hydrogen, more will be these hyperconjugating structures. So this is the, okay, and there will be one more hyperconjugating structure, and rest remain same. Okay, so you can see this structure, and this structure. The total we are having three hyperconjugating structures, as we have three alpha hydrogens because of three alpha hydrogens. Okay. Hyperconjugation it is also known as no bond resonance. It is a permanent effect. Okay. What are the conditions for hyperconjugation? First is the compound should have at least one sp2 hybrid carbon. The compound should have at least one sp2 hybrid carbon of either alkene or alkyl carbocations or alkyl free radicals. Okay. Alpha carbon with respect to sp2 hybrid carbon atom. Alpha carbon in respect to sp2 hybrid carbon should have at least one hydrogen one alpha hydrogen atom attached to it. Okay, these are the two conditions. Types of hyperconjugation. Before we are going to discuss the types of hyperconjugation, I just wanted to give you a glimpse that what hyperconjugation is and how it works. For example, we change the slide. For example, we are having this group. Now, this pi bond alternate with sigma bond, alternate with a group having carbon hydrogen sigma bond. That's important. In pi bond or a positive charge or a free radical should be in conjugation with a carbon hydrogen sigma bond. This is carbon hydrogen sigma bond. Now what happens when the bond electrons will be shifted? Minus plus. So basically this carbon it acquires a positive charge because of not having an electron in its p orbital. So this positive charge needs to be renderized, needs to be neutralized. That is why the hydrogen sacrifices its own electron. The electron will be sacrificed, the electrons will be sacrificed, and this carbon, carbon number 1, and this carbon, carbon number 2, they make a pi linkage. Okay, this is known as what? No bond resonance. Similarly, when one by one the hydrogen they will sacrifice their electrons to the vacant p orbital of this carbon, they will show a hyperconjugating structure. As we have three hydrogens here, so there will be three hyperconjugating structures. Okay, this is what hyperconjugation is. Now types of hyperconjugation. First is sigma, that is carbon hydrogen vacant orbital. Vacant orbital means positive charge hyperconjugation, as I have shown you. Okay, it occurs in alkyl carbocations. Okay, so number of alpha hydrogen 3. Number of alpha hydrogen 6. Number of alpha hydrogen 9. Okay. Second type is sigma, means carbon hydrogen bond, and pi hyperconjugation. It occurs in alkenes. Okay, like 3, 6, 0. Okay. Sorry. Number of alpha hydrogen 1. Okay. That is why the stability of a carb-cation associated with carbon-carbon double bond, it cannot be explained by inductive effect, and that is why we have to introduce hyperconjugation. That's very important. Okay, in this case, okay, you are having three alpha hydrogens here. Okay, because the carbon-carbon double bond next to the carbon, it's carbon is having three. Carbon-carbon double bond next to the carbon is one. Carbon-carbon double bond next to the carbon is zero. Okay, then comes the third category, in which sigma carbon hydrogen and odd electron hyperconjugation. It is seen in free radicals. Okay, like alpha H3, okay, alpha alpha, six alpha hydrogens, okay, alpha, nine alpha hydrogens, okay. Carbonine never shows hyperconjugation. Okay, so please remember this point that carbonyls they never show hyperconjugation. Means there is one carbon hydrogen sigma bond which is alternate with the negative charge. There will be no hyperconjugation effect. Okay. Order of effectiveness of hyperconjugation is alpha carbon hydrogen bond, then alpha carbon deuterium bond, then alpha carbon tritium bond. Okay. Now comes the application part, where we are going to apply the concept of hyperconjugation. To find out the stability of carpetines. In this, you have to remember more number of hyperconjugating structure, more will be the you know hyperconjugation, more will be the stability. The stability of alkyl carpetines is directly proportional to the number of hyperconjugating structures. Okay, which is directly proportional to number of alpha hydrogen. Second is stability of alkenes. It is also directly proportional to number of alpha hydrogen, number of H structures, hyperconjugating structures. Okay, like for example, in case of here, it is more symmetrical. Okay, more number of alpha hydrogen, alpha carbon, alpha carbon, alpha carbon, alpha carbon. Okay, this is more stable. Then third. Understood? Then comes stability of alkyl free radicals. Stability of alkyl free radicals can be explained by hyperconjugation. Okay, stability depends upon number of hyperconjugating structures. Directly proportional to number of hyperconjugating structures. Okay, methyl free radical, alpha hydrogen is 0. Ethyl free radical, alpha hydrogen are 3. Isopropyl, alpha hydrogen are 6. And tertiary butyl, alpha hydrogen are 9. So this will be more stabilized. Understood? Now bond length in alkenes. All these are evidences that hyperconjugation is a important criteria factor to explain the stability of reaction intermediates. Bond length in alkenes. More will be the number of hyperconjugating structures, more will be the single bond character. More will be the number of hyperconjugating structures. Structures. More will be single bond character. In carbon-carbon double bond. In carbon-carbon double bond. Okay. The bond length between carbon-carbon double bond is directly proportional to number of hyperconjugating structures. Okay, like for example, the bond length is suppose P, the bond length is suppose Q, the bond length is suppose R. Okay, so you can see the carbon-carbon double bond, there are alpha hydrogen, carbon-carbon double bond, 3 alpha hydrogen, carbon-carbon double bond, 0 alpha hydrogen. There will be no alpha hydrogen here. Okay, so the P will be maximum stabilized, then Q, then R. Understood? Electron releasing groups. Okay, or we can say minus R in alkyl benzenes. That is toluene is stabilized both by inductive and hyperconjugation. And hyperconjugation. Okay, the orthoparadictic influence of toluene is because of hyperconjugation mainly, and to some extent by inductive. Okay, electron donating power is of alkyl group is dependent upon number of hydrogen present on alpha carbon. Okay, like CH3, 3 alpha hydrogen, CH3, CH2. This is the alpha hydrogen. This is the alpha carbon. 3, 2, 1, 0. 0. Okay. Next is heat of hydrogenation. It is the amount of heat evolved when 1 mole of any unsaturated hydrocarbon are hydrogenated are hydrogenated. Okay. If a alkene is more reactive towards hydrogenation, it will liberate more delta H, heat of hydrogenation. Okay. And heat of hydrogenation is inversely proportional to the stability of alkene. Heat of hydrogenation delta H is inversely proportional to stability of alkene. Also inversely proportional to number of alpha hydrogen. Okay. Heat of hydrogenation is directly proportional to number of pi bonds. It is an exothermic process. Okay. For example, CH2 double bond CH single bond CH2 bond CH3. Here you can see the double bonded carbon. Okay. And when we compare this compound with okay, so this compound will be more stable, okay, as it is having less amount of heat of hydrogenation. Okay, because this carbon, these two carbons, they are having one hydrogen. This is two hydrogen, this is one hydrogen. Okay, heat of combustion. It is the energy liberated during complete combustion of an organic compound. Of an organic compound. Okay. Heat of combustion is inversely proportional to stability of hydrocarbon. Like you have seen this double bonded carbon is having only one electron releasing group. This double bonded carbon, they are having two releasing groups. So more number of the electron releasing group, lesser will be the stability. Okay. As we are decreasing the carbon number of the cyclic chain, the heat of combustion is decreasing. Okay. It is having 9 alpha hydrogen, 5 alpha hydrogen, 2 alpha hydrogen, 1 alpha hydrogen. Which is having more alpha hydrogen, then heat of combustion will be less. So if this is D, C, B, and A, for the correct order will be D, D, C, B, and A. These are the relative orders of heat of combustion and heat of hydrogenation. Then the reverse hyperconjugation. For example, in this system, the effect operates in reverse direction. Hence, the hyperconjugation such system is known as reverse hyperconjugation. Okay, where X is halogen, like for example, okay. So it is having three chlorine. It means it will show three hyperconjugating structures. And the last is the meta directive influence and deactivating effect of CX3 for electrophilic aromatic substitution. Okay, so this is all about the hyperconjugation, my dear students. I hope you got it. If you're having any problem, we'll address your problems. Okay, next topic is the electromagnetic effect. Electromagnetic effect, also known as E effect, it is a temporary effect. Okay, the organic compounds having an unsaturation show this effect. Unsaturated compounds. Okay, it came into action only in the presence of attacking region. That is the, it is known as what, temporary effect. It includes complete transfer of shared pair of electrons to one of the atoms joined to the multiple bond on the demand of attacking agent. Okay, the effect gets vaporized or vanished soon after the removal of attacking reagent. Okay, electromagnetic dominates over inductive effect. It is of two types: positive or plus E, negative or minus E. Plus E, and the pi electrons of the multiple bond are transferred to that atom to that atom to which the reagent gets attached. reagents gets attached to. For example, if the pi bond is shifting here and the attacking reagent is attacking on that particular carbon which is having the receiving of pi electrons, it is known as what? Positive electromeric effect. Okay. Negative is vice versa. When pi electrons of multiple bond are transferred to that atom to which the attacking reagent does not attached, to which the attacking reagent does not attached. Okay, this is negative electromagnetic effect. So this is hyperconjugation and the electromagnetic effect. I will be starting with the carbenes and nitrines in the next turn. Okay, followed by aromatic compounds or aromaticity. Till then, bye bye. Take care. Stay safe. Stay healthy.